Do you know that with the use of algebraic formulas, we can find the value of x in this nice radical maths problem? Don't worry, join me as we find the value of x using algebraic formula. As easy as this may seem, if you don't take care, you might get it wrong. Watch me as we discover and solve this question using the algebraic formula. Don't forget to give this video a thumbs up if you love it, subscribe to my channel and share it with friends and colleagues. Now let's get started. The first thing I'm going to do is to take the negative 1 to the right hand side. That way I can easily take the square of both sides to somewhat work on the square root sign. Now let's see how that works out well. Looking at this expression, taking negative 1 to the right hand side, I'll have to add 1 to both sides. So if I add 1 to both sides, 1 will have to cancel out 1 on the right hand side, and I will be left with x root of x equal to 1. Great. So from here, what do I do next? From here, I'm going to take the square of both sides. If I take the square of both sides, I'm going to have x root x all squared, and this will be equal to 1 squared, right? So why do I have to take the square of both sides? Now remember the law of indices, that if I have a multiplied by b all to the power of x, I can simply separate this index to give me a to the power of x multiplied by b to the power of x, right? Good. If I can simply express that or break up that, that means I can also break up this. So if I break up that, I'm going to have the value of my x all squared multiplying the square root of x all squared, and this will be equal to 1, because 1 square is still what? Is still 1. So if I simplify this, you'll come to notice that the square root will have to cancel out the square, and then I will be left with x squared multiplied by x equal to 1. Now from this expression, I can see something coming out. Remember the law of indices. If I have this expression a to the power of x multiplying a to the power of y, the multiplication law of indices, the exponent or the index will have to what? To add up, and that will be x plus what? Plus y. So if I do that to this expression, remembering that I have 1 here, that whole expression will give me x to the power of 2 plus 1, right? And this will be equal to 1. Great. Now 2 plus 1 is going to give me what? 2 plus 1 is going to give me 3. So I'll have x to the power of 3 equal to 1. Now at this point, I can simply take the 1 back to the other side. If I take 1 back to the other side, and that will lead me into subtracting 1 from both sides, this expression will now give me x to the power of 3 minus 1 to the power of 3 can still be equal to 1, right? And this will be equal to 0. Now watch this expression very well, and this is where we will bring in the algebraic formula. Now recall this algebraic expression, that if I have a to the power of 3 minus b to the power of 3, according to this algebraic expression, this will give me the value of a minus b, right, on one side, and then I'll have the first square, that is a square, plus the first and the second, a plus a multiplied by b, and the last, which is what? Plus b squared, right? Because I have negative sign tying the two. So if you remember this expression, you come to see that a is equal to x from our solution, and then our b is equal to 1. Now let's apply that to our solution. If we apply that, we're going to have x minus 1 as this, multiplying x squared plus x multiplying 1 plus 1 what? 1 square, and all this will be equal to 0. Great. Now let's simplify this. If we simplify this, we're going to have x minus 1 multiplying x squared plus x. 1 square is going to give us plus 1, and all these will be equal to 0. Now, recalling the zero product rule, I can simply isolate these two, having my x minus 1 to be equal to 0. I can equally have my x squared plus x plus 1 to be equal to 0. Great. So if I simplify the left-hand side, adding 1 to both sides, I can have my x to be equal to 1 as the first solution to that mathematical expression. Now, solving this other side, I can compare this expression with ax squared plus bx plus c equal to 0, which shows me it's a quadratic equation where a is equal to 1, b is equal to 1, and then my c is equal to 1. So applying the quadratic formula to find the value of my x will be equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a. Great. Now let's simplify this. Substituting the value of a, b, and c, we'll have our x to be equal to negative 1 plus or minus the square root of 1 square minus 4 multiplied by 1 multiplied by 1, which is c, right? And all these will be divided by 2 multiplied by 1. Great. So the value of our s will be equal to negative 1 plus or minus the square root of 1 minus 4 times 1 is going to give us 4, divided by 2 times 1 is 2. So that expression is going to give us our x to be equal to negative 1 plus or minus the square root of negative 3, and all this will be divided by 2. Great. If we simplify that further, we'll have the value of our x to be equal to negative 1 plus or minus the square root of negative 1 multiplied by 3, right? All divided by 2. According to the law of square root, we are going to expand that square root, and this will give us what? Negative 1 plus or minus the square root of negative 1 multiplying the square root of 3, and this will be divided by 2. So that expression is going to give us the value of our s to be equal to negative 1 plus or minus square root of 3. Recall, according to complex number, square root of negative 1 is equal to j. So this is going to give us j divided by 2. And this is another solution to that mathematical expression. So the value of our x from those expressions, the value of our x1, we got it as 1, our x2, we got it to be equal to negative 1 plus square root of 3i or j divided by 2, and our x3 is equal to -1 plus or minus the square root of 3j divided by 2. This is going to give us a negative because the first is what? A positive. And this is the solution to that mathematical radical maths problem given to us up there. I know you did enjoy watching this math solution. Don't forget to give it a thumbs up, share it with friends and colleagues, and remember to subscribe to my channel for more simplified math content. Thanks so much for watching, and bye bye for now.